random process x of t is equal to a cos omega naught t plus theta is not stationary if a and omega are constants and theta is uniformly distributed in the random variable in the interval 0 to pi. Here, given the random process x of t is equal to a cos omega naught t plus theta and theta is uniformly distributed in the interval 0 to pi. If theta is uniformly distributed in the interval 0 to pi, its probability density function PDF can be written as f of theta, which is equal to 1 by pi minus 0 in the interval 0 less than theta less than pi and 0 elsewhere, which is equal to f of theta is equal to 1 by pi 0 less than theta less than pi and 0 elsewhere. Now we'll have to find the expectation of x of t. Expectation of x of t is equal to expectation of x of t is given as a cos omega naught t plus theta. A cos omega naught t plus theta. Here a is constant, so it can be taken outside. The expectation of e cos omega naught t plus theta, which is equal to a into integral of cos omega naught t plus theta into f of theta d theta over theta, that is a into integral 0 to pi cos omega naught t plus theta into 1 by pi d theta, that is equal to a into 1 by pi is also a constant, so it can be taken outside. A by pi integral 0 to pi cos omega naught t plus theta d theta, that is equal to a by pi sin omega naught t plus theta from the limit 0 to pi. So now limit can be applied. So upper limit can be applied. If upper limit is applied, we can write a sin omega naught t plus pi minus sin omega naught t plus 0, which is equal to a by pi sin omega naught t plus pi minus sin omega naught t, that is a by pi sin omega naught t plus pi can be written as omega naught t sin pi plus omega naught can be written as minus sin omega naught t minus sin omega naught t, which is equal to minus 2 a by pi into sine omega naught t, which is a function of a time t, so it is not a constant, not equal to a constant. If a random process is stationary, it should not be a constant. It should be a constant. It should not be a function of time. So it should not vary with the time. Therefore, x of t is not stationary process. If x of t is equal to sine omega t plus y, where y is uniformly distributed in the interval 0 to 2 pi, show that x of t is wide sense stationary. Here given x of t is equal to sine omega t plus y, and also one more condition is given: y is uniformly distributed in the interval 0 to 2 pi. Now we can write the probability density function of y. F of y is equal to 1 by 2 pi minus 0 and the interval 0 less than y less than 2 pi and 0 elsewhere. That is, f of y is equal to 1 by 2 pi 0 less than y less than 2 pi and 0 elsewhere. Now we'll have to find expectation of x of t. Expectation of x of t is equal to expectation of sine omega t plus y. Here y is a random variable and it is uniformly distributed in the interval 0 to 2 pi. Now expectation is equal to integral over y sine y t plus sine omega t plus y into f of y dy. That is equal to integral 0 to 2 pi sine omega t plus y into 1 by 2 pi dy. Here 1 by 2 pi is a constant which can be taken outside. That is 1 by 2 pi into integral 0 to 2 pi sine omega t plus y dy. That is integral of sine omega t plus y is equal to minus cos omega t plus y from the limit 0 to 2 pi. That is 1 by 2 pi. Now we can apply the limit directly. Upper limit is 2 pi cos omega t plus 2 pi minus of cos omega t plus 0. That is equal to 1 by 2 pi minus cos 2 pi plus omega t plus cos omega t. Cos 2 pi plus theta, which is equal to cos theta, which comes in first quadrant, so we can write cos 2 pi plus theta is equal to cos theta. That is 1 by 2 pi minus cos omega t plus cos omega t, that is equal to 1 by 2 into 0, which is also a 0, is also a constant. Now we will have to find its autocorrelation. What is autocorrelation? By definition, autocorrelation is RHS of t1 comma t2 is equal to expectation of x of t1 into x of t2. Here, given x of t is equal to sin omega t plus y. So x of t1 is equal to sin omega t1 plus y, and x of t2 is equal to sin omega t2 plus y. X of t1, expectation of x of t1 into x of t2 is equal to expectation of sin omega t1 plus y into sin omega t2 plus y. Now it is in the form sin A sin B. What is sin A sin B? Sin A sin B is equal to we can write sin A sin B. Sin A sin B can be written as sin A sin B is equal to 1 by 2 cos A minus B minus cos A plus B. Cos A minus B. Cos A, here A is equal to omega t1 plus y. B is equal to omega t2 plus y. Cos A minus B is equal to cos omega t1 plus y minus omega t2 plus y. So it is equal to cos omega t1 minus omega t2. Y cancels out, which is equal to cos omega t1 minus t2. Now we can write cos is an even function, so cos of minus theta is equal to cos theta. So which is equal to cos omega of minus t2 minus t1, that is equal to cos omega of t2 minus t1. Since cos is an even function, now cos A plus B. Cos A plus B is equal to, what is A? A is omega t1 plus y and B is omega t2 plus y. Now cos omega t1 plus t2, now omega can be taken outside from this two terms plus 2y. So expectation of sine omega t1 plus y into sine omega t2 plus y can be converted into 1 by 2 cos a minus b cos omega t1 plus y minus omega t2 plus y minus cos omega t1 plus y plus cos omega t2 plus y. One more bracket is there. 1 by 2 can be taken outside. Expectation, these terms we can convert it into cos omega t2 minus t1 minus cos omega t1 plus t2 plus 2y. Here this term is free from y. Y is the random variable, so it can be treated as a constant. 1 by 2 expectation of cos omega t2 minus t1 minus expectation of cos omega t1 plus t2 plus 2y expectation of a constant is a constant, so 1 by 2 into, this is a constant, 1 by 2 into cos omega t2 minus t1 minus 1 by 2 into expectation of cos omega t1 plus t2 plus 2y. Now expectation of cos omega t1 plus t2 plus 2y is equal to integral over y cos omega t1 plus t2 plus 2y into f of y dy, that is equal to integral over 0 to 2 pi cos omega t1 plus t2 plus 2y, f of y is 2 pi dy is equal to 1 by 2 pi. 1 by 2 pi is constant here, so it can be taken outside the integral. Integral 0 to 2 pi cos omega t1 plus t2 plus 2y into dy, that is equal to 1 by 2 pi sine integral of cos theta is equal to sine theta into sine of omega t1 plus t2 plus 2y, the whole term divided by 2 from the limit 0 to 2 pi. Now we can apply the upper limits to this function, that is sine omega 1 by 2 can 1 by here 1 by 2 can be taken outside. Sine omega t1 plus t2 plus 2 into 2 pi is 4 pi minus sine omega t1 plus t2 plus 0. Any sine 4 pi plus theta is equal to sine theta. So 1 by 4 pi sine omega t1 plus t2 minus sine omega t1 plus t2, which is equal to 0. Now substitute these two equation 1. We get Rxx of t1 t2 is equal to 1 by 2 cos omega t2 minus t1, which is a function of time difference t2 minus t1, that is 1 by 2 cos omega 2. Here 2 is equal to t2 minus t1. Therefore x of t is a WSS process. The process x of t whose probability distribution under certain condition is given by p of x of t is equal to n, which is equal to at raised to n minus 1 divided by 1 plus at, the whole term raised to n plus 1, comma n is equal to 1 2 3 etc., and which is equal to at by 1 plus at where n is equal to 0. Show that it is not stationary. Given x of t is equal to n, we can write it in a table, and p of n is equal to n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3, etc. If n is equal to 0, the condition is already given, at by 1 plus at, and if n is equal to 1, at raised to n minus 1, that is 0. Any number raised to 0 is 1. So 1 by 1 plus at the whole square. Then if n is equal to 2, at by 1 plus at raised to 3. If n is equal to 3, at square by 1 plus at raised to 4, etc. Now we have to find expectation of x of t. Expectation of x of t is equal to This function is a discrete function, so we use summation n is equal to 0 to infinity n into p of n. That is, if n is equal to 0, n is equal to 0, p of n is equal to 0 into 80 by 1 plus 80, plus if n is equal to 1, 1 into 1 by 1 plus 80 square, plus 2 into 80 by 1 plus 80 cube, plus 3 into 80 square by 1 plus 80 raised to 4, plus etc. That is, this term becomes 0. 1 by 1 plus 80 square plus 280 by 1 plus 80 cube plus 380 square by 1 plus 80 raised to 4 plus etc. Every term contains every term denominator contains second order power of 1 plus 80, so we can take it outside. 1 plus 80 square into 1 plus 80 can be taken as 280. If 1 plus 80 can be taken outside, this becomes 80 by 1 plus 80 plus 3 into 80 square divided by 1 plus 80 the whole raised to 4 plus etc, which is equal to this. There is a function. What is it? If this term becomes, this is like that, 1 plus 2x plus 3x square plus etc, which is equal to 1 minus x the whole raised to minus 2. Here x is equal to 80 by 1 plus 80. Now 1 by 1 plus 80, this series becomes 1 minus 80 by 1 plus 80 the whole raised to minus 2 is equal to 1 by 1 plus 80 into 1 plus 80 minus 80. Denominator can be multiplied into this term. We can will obtain 1 by 80 square, which is equal to, this becomes 1 by 1 plus 80 the whole square into 1 by 1 plus 80 the whole raised to minus 2. This becomes cancels out. We will get a constant, which is a constant. Next is expectation of x square t, e of x square t, which is equal to summation over n is equal to 0 to infinity n square into pn. Summation over n is equal to 0 to infinity. We'll have to do some modification in this n square. N square can be written as n into n plus 1 minus n into p of n. which is equal to summation over n is equal to 0 to infinity n into n plus 1 into Pn minus summation over n is equal to 0 to infinity n into Pn. Take it as equation number 1. Now we'll have to find summation over n is equal to 0 to infinity n into n plus 1 into Pn, which is equal to, put n is equal to 0, 0 into Pn. Pn is 1 by 80 by 1 plus 80 plus, put n is equal to 1, 1 into 2 into 1 by 1 plus 80 the whole square plus, put n is equal to 2, 2 into 3, 80 square divided by 1 by 1 plus 80 the whole cube. When n is equal to 3, 3 into 4, 1 by 80 raised to 3 divided by 1 plus 80 the whole raised to 4 plus etc., which is equal to 1 into 2, 1 by 1 plus 80 square plus 2 into 3, 80 the whole square divided by 1 plus 80 the whole cube plus 3 into 4, 80 cube divided by 1 plus 80 the whole raised to 4 plus etc. Now plus etc. Yes, which is equal to 2 into 1 minus x the whole raised to minus 3. That is, therefore the function becomes 1 by 1 plus 80 square into 2 into 1 minus, here x becomes x is in term here x is 80 by 1 plus 80 the whole raised to minus 3, which is equal to 1 by 1 plus 80 the whole square, 2 into 1 by 1 plus 80 the whole raised to minus 3, that is 2, this becomes 1 plus 80 to 1 plus 80. Now substitute in equation 1, you will get expectation of x square t is equal to expectation of x square t is equal to summation over n is equal to 0 to infinity, summation over n is equal to 0 to infinity n square into n into n plus 1 into p of n minus summation over n is equal to 0 to infinity n pn. We know that this term already. We have found x e of x of t. This is e of x of t. The value of summation over n is equal to 0 to infinity n into n plus 1 pn is equal to 2 into 1 plus 80, and this term is 1. So 2 plus 280 minus 1 is equal to 1 plus 2at, which is not equal to a constant. Therefore, x of t is not a stationary process. Two random processes x of t and y of t are defined by x of t is equal to a cos omega t plus b sin omega t, and y of t is defined as b cos omega t minus a sin omega t. Show that x of t and y of t are jointly WSS if a and b are uncorrelated random variables with a zero means and the same variance, and omega is a constant. Here x of t, two random processes, one is x of t and the other is y of t, which is given as x of t is given as a cos omega t plus b sin omega t, and y of t is equal to b cos omega t minus a sin omega t. We will have to prove x of t and y of t are jointly WSS. We will have to prove x of t and y of t are jointly WSS. Here some conditions are given. We will have to check what are the conditions. First one, a and b are uncorrelated random variables with zero means and same variances. A and b uncorrelated. Here expectation of a equal to 0 and expectation of b equal to 0. Another condition, variance of a is equal to variance of b is equal to, you can say that, say sigma square, say. And one more condition is given, a and b are uncorrelated random variables. If a and b are uncorrelated, its covariance is or correlation is 0. If correlation is 0, its covariance is also 0. Covariance is defined as covariance of a comma b is equal to expectation of a b minus expectation of a into expectation of b. Covariance is given as 0, which is equal to expectation of a into b minus expectation of a is equal to 0 and expectation of b is equal to 0, which implies expectation of a b is equal to 0. Expectation of a into b is equal to 0. To prove x of t and y of t are jointly WSS process, we will have to prove first condition. We will have to prove x of t is a WSS process. We will have to prove and the y of t is also a WSS. Then Rx y of t1 t2 is also a function of t2 minus t1 or tau. Now move on to first condition. To prove x of t is WSS process, expectation of x of t, we have to find expectation of x of t, which is equal to expectation of a cos omega t plus b sin omega t, which is equal to expectation of A into cos omega t is a constant plus expectation of B into sin omega is also a constant. This is equal to 0 plus 0 which is also 0 which is equal to a constant. Next, RxX of T1 T2. RxX of T1 T2 is equal to expectation of xt1 into xt2. That is xt is given as x of t is given as a cos omega t plus b sin omega t. xt1 is equal to a cos omega t1 plus b sin omega t1. X of t2 is equal to a b cos omega t2 a cos omega t2 plus b sin omega t2. Expectation of x t1 into x t2 is equal to expectation of a cos omega t1 plus b sin omega t1 into a cos omega t2 plus b sin omega t2. Multiply these two terms, you get expectation of a square cos omega t1 into cos omega t2 ab cos omega t1 into sin omega t2 plus ab sin omega t1 into sin omega cos omega t2 plus b square into sin omega t1 sin omega t2. Expectation of a square into cos omega t1 into cos omega t2 plus expectation of ab into cos omega t1 into sin omega t2 plus expectation of ab into sin omega t1 into cos omega t2 plus expectation of b square into sin omega t1 into sin omega t2. If given condition, here already said expectation of we have already said expectation, we have already known expectation of AB is equal to 0. And substitute in this equation, we will get expectation of a square into cos omega t1 cos omega t2. This term becomes 0. 0 plus 0 plus expectation of b square into sin omega t1 into sin omega t2. is equal to expectation of a square into cos omega t1 cos omega t2 plus expectation of b square into sin omega t1 into sin omega t2. We have already known that in question we have already given a condition that variance of A is equal to variance of B is equal to sigma square. But we know that the definition of variance of A is equal to expectation of A square minus E of expectation of A the whole square. Similarly, we can write variance of B is equal to expectation of B square minus expectation of B the whole square. Here, we already know that expectation of A is equal to 0. 0 square minus E of A square, which is also sigma square, and here also sigma square is equal to E of B square minus 0 square. From this equation we know that E of A square is equal to E of B square is equal to sigma square. Substitute in equation 1. The above equation, we can substitute this value. We will get sigma square cos omega t1 cos omega t2 plus sigma square sin omega t1 sin omega t2 sigma square is constant here, we can take an outside common here. Cos omega t1 cos omega t2 plus sin omega t1 sin omega t2. This equation is of the form cos A cos B minus sin A sin B. This equation is of the form cos A cos B plus sin A sin B. It is equal to cos A minus B. Here A is equal to omega t1, B is equal to omega t2. That is equal to sigma square into cos omega t1 minus omega t2, which is equal to sigma square into cos omega t1 minus t2. You know that cos is an even function. Cos of minus theta is equal to cos theta. So we can write sigma square is equal to sigma square into cos omega t2 minus t1, which is a function of tau. Tau is equal to t2 minus t1 cos omega tau. Therefore, x of t is a WSS process. Similarly, we can prove that y of t is also a WSS process. First, for that, first we will have to find expectation of y of t, which is to verify expectation of y of t is equal to a constant and r y of t1 t2 is a function of t2 minus t1 or 2. To prove x of t and y of t are jointly WSS process, we have to find r x y of t1 t2, which is equal to expectation of x t1 into y t2. X t1 is equal to a cos omega t1 plus b sin omega t1. Y of t is equal to y of t2 is equal to b cos omega t2 minus a sin omega t2. Now we will have to find the expectation of x t1 and y t2. Expectation of x t1 into y t2 is equal to expectation of a cos omega t1 plus b sin omega t2 into b cos omega t2, b cos omega t1, b cos omega t2 minus a sin omega t2. Then multiply these two terms, you will get a b cos omega t1 cos omega t2 plus minus a square cos omega t1 sin omega t2 plus b square sin omega t1 cos omega t2 minus ab sin omega t1 sin omega t2, which is equal to expectation of ab into cos omega t1 cos omega t2 minus expectation of a square into cos omega t1 sin omega t2 plus expectation of b square into sin omega t1 cos omega t2 minus expectation of ab into sin omega t1 sin omega t2. We already know that expectation of ab is equal to expectation of is equal to 0 and expectation of a square is equal to expectation of b square is equal to sigma square. This is denoted as equation number 2. Substituting this equation, you will get 0 minus sigma square cos omega t1 sin omega t2 plus sigma square sin omega t1 cos omega t2 minus 0, which is equal to sigma square can be taken outside. Sin omega t1 cos omega t2 minus cos omega t1 sin omega t2. This equation is of the form sin A cos B minus cos A sin B. You already know that sin A cos B minus cos A sin B is equal to sin A minus B. Here A is equal to omega t1 and B is equal to omega t2. It's equal to sigma square sin omega t1 minus omega t2 is equal to sigma square sin omega t1 minus t2. Sin minus theta is equal to minus sin theta. So we can write minus of sin omega t2 minus t1, which is a function of t2 minus t1, or minus sin sigma square sin omega 2. Therefore, x of t and y of t are jointly WSS process.